Thanks for the invite to talk today. I'm going to build on a project that we at AITF worked on 2 or 3 years ago and finished up last year. So we had a project where we worked on how to use existing data throughout Alberta to do what we thought would be a more comprehensive look at cumulative effects analysis, cumulative effects assessment for biodiversity. The project worked well. We were able to show some really neat ways of assessing cumulative effects. But in addition to the science that's involved with cumulative effects, the management landscape has changed a lot in the last few years. So what I'm really going to concentrate on today is not the project that we finished up a year ago. I'm going to mention that a bit. But it's more about, so how is cumulative effects evolving in Alberta? And I stress, these are my opinions. They may or may not be reality. But it's how I see cumulative effects assessment evolving in the society that we have in Alberta. So I'm going to start with just an overview of the project we worked on a couple of years ago. So we did a pilot study of how to use existing information from Alberta to assess cumulative effects. And we worked in this area just south of Fort McMurray. So a fairly broad region. The study area has a variety of different scales. Looking at the map on the left, the bigger yellow line is the 2 caribou ranges. Those 2 caribou ranges there. Inside there's a smaller area that surrounds a couple of leases. And one can assess cumulative effects actually at the lease scale if you wish. So a variety of nested scales to evaluate cumulative effects. The goal of that project was to say, can we use the abundant information that's available to do a cumulative effects assessment at this broad regional scale? And we wanted to then be able to evaluate it at a regional scale, but be able to step down to look at smaller scales as well. So it's a multi-scale analysis of cumulative effects. And we said, given that there's a lot of data, is it possible, doable, to do a whole bunch of complex modeling and make the cumulative effects assessment more robust? When we were looking at what to do in this pilot, there's a whole host of key indicator values that folks have been tasked with looking at. We didn't wish to look at them all. We said, let's choose 6 or 7 things and do the pilot on those 6 or 7 things. That doesn't mean that you can't look at the other key indicators, but we focused on looking at 6 or 7 things as a pilot. So what we did then in this pilot, we said, first, we'll go through and amalgamate as much of the information about the study area as we can. This is just a map of the study area, and you can see places where there's lots of deciduous forest or coniferous forest, and there's a lot of wetlands, bogs and fens in this study region. Those are the purple. And then we said, what is the human footprint in the study area? Cut blocks, pipelines, well sites, cut lines. What are the human footprints in the area? Getting these maps is a big task. Now, after you've done it once, the next person doesn't have to do it again, or the next development doesn't. But getting these maps is not a simple task. But if you take the time to get the maps, you can say a heck of a lot about the study area after that. And in my mind, there's no reason you couldn't share this with everybody. So, to assess cumulative effects, we start with the map of the vegetation. We overlay the map of the human footprint. And I stress, if you look at this map of human footprint, you would think that the seismic lines and well sites in a lease area meant there was nothing else there. That's an exaggeration. The lines, to put a cut line on a map this size, the line is actually 200 meters wide. So, although this looks like all of the native vegetation under the human footprint is removed, that's not true. That doesn't mean that there isn't human footprint there, but many of these human footprints are small and therefore have been exaggerated on this map. In fact, cut lines take up only 3 or 4% of any area, although on here they look like more. But starting with these maps of native vegetation and human footprint, one can then predict what is the consequence of having that human footprint on these indicators. So in the project, we go into gory detail on how to do this modeling and so on. I'm not going to go into that today, but it's quite possible to build from the 2 maps on the left to talk about what is the ecological consequence to a variety of key indicators. And you can see that they're not all the same. Some indicators seem to be more affected than others. And these maps, red means predicted to be more affected. Green means the predicted effect to be low or close to zero. And you can see that some things are more affected than others. And we expected that. So it's not surprising, it's not new, but it's quite possible to use the existing information and make these predictions for quite broad study areas if you choose to go that way. What's neat also, because the predictions are at a quarter section level, one can then drill in. You don't have to stay at the big study area. You can say, yeah, I can see how it happens throughout the whole of the study area, but I'm interested in that particular spot right here. You can drill in and ask questions about any particular spots on the region of which the analysis is done. So it allows you a multi-scale look at how cumulative effects, what are the cumulative effects in the region. And obviously, the cumulative effects vary spatially. I mean, it's a known, it's a given. But this allows you to look at the cumulative effects and how they change spatially throughout the study area. What was also what we did in the pilot, and we did this is really a very coarse evaluation. We didn't have time, we didn't have the resources to do a really good prediction or an evaluation of what human footprint would look like in the future, 25 or 50 years in the future. But we said, if we could develop scenarios, and this is a real scenario, it says the status quo rolled out 25 years and 50 years in the future, coarser. If we did that, we should then be able to then talk about what is the effect or predicted effect on these key indicators 25 and 50 years in the future. And it's not, intellectually it's easy to understand, it's a bit of work, but it was quite possible to do. And we went through and predicted these changes as part of the pilot project. We predicted the changes for each of those 6 or 7 different indicator species. The conclusions, and I'll admit I've not done justice to the study, but I wanted to move on to the part of changing management. The conclusion of the study was, yes, you can use existing information, and there is a lot of existing information, to talk about how things are expected to be affected by existing human footprint in a region. It is quite possible to use existing data to use it, to do that analysis, make the prediction for the broad area, and if you wish, you can drill down to any particular spot within that area. So you can summarize the information, talk about the information, talk about cumulative effects at a variety of scales. This is quite possible to do. It's not a gimme in that it takes a fair bit of effort by people to do it, but it's quite possible to use our existing information to make it happen. What became obvious in spades as we were finishing up the project was that although the project was initiated by industry and strongly supported by this AUPRF funding, the process to make it happen, because this is across broad areas, across a variety of industries, across a variety of companies, it's going to have to be a government-led process. Expecting any particular industry to do this is unrealistic. And so, although it was possible to do it, the probability of it happening as an industry-led initiative seemed unlikely. And that's kind of where we ended up at the end of the study of saying, yeah, it makes sense, but is it ever going to happen? And I mean, I'd like to say there looks like, yes, it will happen, or at least all indications are as that we are a society are moving down the road to make this kind of stuff work. So that's the rest of this presentation will be on. So that's what I talked about, the evolving landscape. The future is changing. Where we started out 20 years ago, and we're still kind of there, is that we expect individual developers to do cumulative effects. But as a society, we are starting to change that expectation. The regulators, provincial government, possibly even federal government, are starting to promote the idea that it should not be led by industry developments, it should be led by the regulator. And there's a variety of things that the regulator has implemented to make this cumulative effects more effective. And really, in my mind, all these things, all they're doing is creating the environment that allows the analysis that we did in the pilot to actually happen. And there's four different bullets listed there of the kinds of things that we as a society are presently doing. I'm going to step through each of those throughout the rest of the presentation. But I'd like to put a note of caution on this. It's an evolving system. Although folks are moving down this road, it's moving in fits and starts, and none of it really moving. It's not as coherent as you might hope it will be. And as we move from the status quo to the new system, there's going to be a bit of anxiety and a bit of things that don't always work out the way you'd hope it will. So it's an evolving process, and we'll have some uncertainty as we move down. However, I just take that as a given and say there still are some good things happening. So I'm going to step through those bullets. The land use framework, I think everybody in this room is well aware of it. There's 7 different regions throughout the province. In each of the regions, the goal is for, as part of a planning process, folks travel throughout the province, meet with stakeholders to develop a desired future state for that region. What do we as society want to get from our 7 different regions? And many of the same things are shared amongst regions, but not everything is shared amongst regions. In addition, folks recognize as part of this process, we do need good information and we need good tools to manage to achieve those desired future conditions. Key to the land use framework, especially from a biodiversity standpoint, is that it's not just about developing desired future conditions, it's putting in a framework that allows us to achieve those desired future conditions. And so as part of that, there is a biodiversity management framework. I think our provincial government is keyed on frameworks. They seem to have a framework for this and a framework for that. However, we got a lot of frameworks, but the biodiversity management framework is a separate one is being developed for each of the land use framework regions. And the biodiversity management framework builds on the biodiversity management, the Alberta Biodiversity Strategy. What's different about the biodiversity management framework and the traditional cumulative effects assessment is that we still have indicators in the biodiversity management framework, but we also have targets, thresholds, and management strategies. Ordinarily, when we did cumulative effects, we assessed cumulative effects, but the setting of the targets and thresholds and triggers was an outside process. Those triggers and targets are now being built explicitly in the biodiversity management framework. The goal is this framework helps the land use framework assess whether or not the desired future conditions are being achieved. So the BMF is a cumulative effects assessment, but it builds in targets and thresholds. That's a major advancement, a major change. The BMF is the management framework for indicators and so on. Many of you will probably have seen some of this. I'm not sure that everybody has. But there is, from a biodiversity standpoint, there are 4 pyramids that are developed for each of the region. 2 of the 4 pyramids deal with species, 2 of the 4 pyramids deal with habitats. And then, so there's a terrestrial species and aquatic species pyramid. There's a terrestrial habitat and aquatic habitat pyramid. The BMF has focused on saying we want to have 3 indicators in each of the pyramids, so a total of 12 indicators, and for those 12 indicators there will be targets and thresholds developed. The expectation is there are way more than 12 key indicator resources in any region. So there's also then a whole slew of other key resources that are monitored and tracked, but there are no targets and thresholds developed for them. So there's 12 indicators that have targets and thresholds. The remaining are still tracked, but we're not, as a society, we're not developing thresholds for them. For the lower Athabasca, these are the 12. Now, these aren't written in stone, but there's getting to be strong support that these are the ones that at least initially will be tracked within the lower Athabasca region. Along with this development of a biodiversity management framework is the need to have information that supports evaluation, tracking the kinds of things you need to evaluate whether or not you are achieving the goals for those target indicators, those key resources. So ABMI has been promoted as the vehicle for which we would use to track status and changes of widespread species. This is not the same as tracking common species. There's a whole host of relatively uncommon species that are widespread and very well tracked within the ABMI from a wide variety of different taxa. So the ABMI is, the design of there is to track these multitude of widespread species to evaluate changes in those critters over time. In addition, as part of the ABMI, we do a fair bit of work on mapping and monitoring changes in habitat conditions, the vegetation and the human footprints. I'm going to give you just a little bit of information about how status and trend are tracked within the ABMI, partly because it's my baby and I know lots and lots about it, but I do think it's interesting as well. So one takes information that's collected at a variety of sites throughout Alberta, couples it with vegetation and habitat that is mapped throughout Alberta to create models. Just think of it as analysis, to evaluate how critters vary among habitats and in response to human footprint. I'll give you an example of one species. So this is just one of hundreds of species. Ruby-crowned kinglet. I chose it because I like them and I'm a bird ecologist. But there's no other reason. You could choose any species. But ruby-crowned kinglet. And you'll see all one does, if you look on the Y scale, is the relative abundance of ruby-crowned kinglet. The groups of bars are spruce. So let's think white spruce, pine, mixed-wood habitat, deciduous, and lowland conifer. Think black spruce and larch. The little bars are different age classes. So 0 to 20 years, 20 to 40, 40 to 60, and so on. So you can see that ruby-crowned kinglet varies amongst the different habitats. The 3 bars on the end are grassland, shrub, and wetlands, swamps and bogs and fens. So obviously, ruby-crowned kinglet varies among habitat. We knew that. But all this does is mathematically show how ruby-crowned kinglet varies among habitats. One can look also, how does ruby-crowned kinglet vary as we change the amount of human footprint in the area, right in the area they're using? And you can see, for the biggest part, ruby-crowned kinglet tend to decrease as we get more and more human footprint in the area. You couple those pieces of information with information about vegetation and information about human footprint, one can predict then what is the expected abundance of ruby-crowned kinglet in every quarter section throughout the province. Red means relatively high abundance, white or blue, relatively low abundance. And so all this is a predictive map. It says, given these relationships on the right and the maps at the bottom, this is what I would expect to find for ruby-crowned kinglet abundance under conditions where we've removed the human footprint. We've filled in the vegetation to backfill the human footprint throughout Alberta. One can then also say, what is the expected change in abundance of ruby-crowned kinglet because we presently have human footprint? So if we say, given that we don't have backfilled vegetation, what is the expected change from that reference condition given that we have a human footprint already present? And pink means they are less abundant, green means they are more abundant in that quarter section. Again, this is a predictive map. But this is really a cumulative effects assessment for ruby-crowned kinglets. It just says, what have we as society done to change the abundance of ruby-crowned kinglet from what it would have been if we weren't here? So it's a cumulative effects assessment for ruby crowns. You can do the same for any species where you have the data. This is the data for moose. You can do it for individual species. You can average it across a group of species if you want. You can say, I'm just interested in old forest birds, or I'm only interested in wetland plants. So you can do it for species, groups of species, or you can do it for all biodiversity. And this is just a map of summed up across a couple or 300 different species. And it says quarter sections in Alberta, some of them are relatively similar to what we expect naturally, and some of them are quite different. And it totally makes sense. I mean, the places where we have changed the most have biota that are least similar to natural. It's a prediction of the present cumulative effects of biodiversity throughout Alberta. This kind of stuff is quite doable if you have the data and take the time to do the modeling. Along with modeling those relatively widespread species, as part of the work that was done in the lower Athabasca, as part of the Joint Oil Sands Monitoring Initiative, we said there are things that don't fit within ABMI. And there then needs to be other programs put in to monitor these other things. So some of you folks may be well aware of the EMCLA, the Environmental Monitoring Committee for the Lower Athabasca. And they tackled a set of critters, things that weren't well tackled by ABMI. In addition, Environment Canada is really concerned, really focused on birds. So there's a variety of bird species that are rare and patchy that aren't well tackled by ABMI, so there's additional monitoring put in on those. Fish and Wildlife has a strong focus on ungulates, so there's additional monitoring put on ungulates. We can do the same type of analysis, the same type of prediction for all of these critters if we get reasonable data. It's a matter of getting reasonable data. And at this stage, folks in the lower Athabasca are attempting to get that reasonable data. There are still holes. As a society, we aren't monitoring fish communities. We just aren't. And it's not that we don't want to. It's not that we say we shouldn't. It's just that we haven't allocated the resources to do a good job on it. The same thing goes for fur bearers. The same thing goes for rarer species that are not vertebrates. I mean, we don't really monitor rare plants. We definitely don't monitor rare lichens. It's just, we just don't do it. That doesn't mean we couldn't, and doesn't mean we couldn't then do cumulative effects for it. But we would have to allocate the resources to make it happen. And the other thing that I think we need to think about as we're doing cumulative effects is we have reasonable maps of vegetation. We have reasonable maps of footprint, but they're reasonable. They may or may not be perfect. No, they are not perfect. We can make them better if we're willing to spend the resources to do that. The last thing that I'd like to touch on is in the last 2 or 3 years within the land use framework and ESRD, there's been a group that said, you know, we can internalize this cumulative effects assessment. So they said, let's do a pilot in the southern oil sands region. It happens to be the same region that we did the AUPRF project within. And they borrowed a whole bunch of our analysis, and they didn't acknowledge me the way I wanted them to. However, that's just the way it is. But so they said, we can do a pilot project in the South Oil Sands region. But they expanded it. It's not just biodiversity, it's air, water, land, and biodiversity. That's a neat step forward. And the results from that initiative, expectation is that they will have start to release some results right after Christmas. Hopefully, lots of results by the end of March, but the goal is right after Christmas to start releasing some results. It's a pilot project, but it is where folks are moving in the future to do cumulative effects assessment. and within that group, they're definitely promoting this is the way to do cumulative effects. So, conclusions. Cumulative effects is changing. It just makes sense to do this more detailed monitoring evaluation at a broad regional scale so that you can drill down into other smaller regions. There are still some holes in the data. There will always be holes in the data. As a society, we need to decide which holes we wish to fill. The process is becoming government-led. It's not there yet, but it's becoming that way. And we need, as a society, we need to recognize that this is a transition. There will be places in that transition that are rough, that great as we move through it. Having said that, I think the goal is well worth it.